Hi everybody, I thought we'd have a look at 2 points and how 2 points or 1 point in a gradient can be used to find the equation of a line. So if we have 2 points, we can determine the equation of a line that passes through the 2 points. So here we have a case where a line passes through 2 points A and B. We can find the gradient of that line by using the formula m equals rise over run. So from point A to point B, the line rises 2 and runs 1. So we put the rise on the top, we put the run on the bottom. And in the case of 2 divided by 1, that simplifies down to 2. So our m value in our slope-intercept form will be 2. And there it is there. Now on this graph here that we've been given, we can see that the y-intercept is 1. So we can just plonk 1 on the end. This equation here, y equals 2x plus 1, represents every point on this blue line. Okay, case number 2. We have 2 points A and B. This time point A is 2, 3, and point B is -3, -1. Similar to what we did before, we can establish the gradient. The rise goes from 1 to 3, so there's 4 altogether, 1 to here and 3 more up to there. And the run from here to here, the horizontal distance between B and A, would be from -3 to 2, so 3 on this side, 2 on that side, 5 total. It's run 5. Our gradient is 4/5. We can plonk that straight into the equation. But what's a bit more difficult this time is that we haven't been given the y-intercept, so we're going to have to find it out. Now to do that, we can substitute into y equals mx plus c. We just need the gradient that we found and one of the coordinate pairs. It doesn't matter which one we choose. In this case I've chosen 2, 3. So where we would normally put y, I've put 3. Where we put x, I've put 2. And now I've got an equation, one unknown, it can be solved. This becomes 8 over 5. Here, I've swapped the sides over to make it a bit neater. Subtracted 8 over 5 from both sides. Multiplied by 5 over 5 to make 15 over 5, so I can subtract the 2 fractions, and I get left with 7/5. So c is 7/5. I can now plonk that on the back of my equation where the c goes. And I now have an equation that represents this blue line here. It's y equals 4/5 x plus 7 on 5. Case 2. Case number 3. What if we're given a gradient and a point, not 2 points? Well, we can do something a bit nifty here. We know that the gradient formula is y take y1 on x take x1. Y take y1 will give us the rise. X take x1 will give us the run. It's just the difference between y and y1 and x and x1. Which gives us this equation here instead of the familiar rise over run. Now if I multiply both sides by x take x1, I get this equation here. So y take y1's on one side and m x take x1's on the other. And we can use this to find the equation of a line. It's not as popular as it was, say, when I was a young lad, but it still works. So if we have a look at the familiar case we've been looking at, if m equals 2 and a line passes through 1, 3, find the equation of a line in slope-intercept form. We take this equation from up here and we put 1, 3 in y1 and x1. So you can see over here I've labelled it x1 and y1. And over here where y1 goes, I've put the 3. And over here where x1 goes, I've put the x. Remembering to subtract in both cases because our general form tells us to do so. Over here I've put m as per our general case up here, and that's given us an equation. Now if we simplify that equation, multiply out this bracket, we get this. Add 3 to both sides, we get this, and lo and behold, we've got an equation in slope-intercept form. So if we have a line with a gradient of 2 that passes through 1, 3, the formula will be y equals 2x plus 1. The line here will pass through the y-intercept at 1. Great. Could we have done this another way? Yes, we could have. We didn't have to know anything about this equation, which is why it's not taught as often anymore. We could have done it just with slope-intercept form. So again, if the gradient was 2 and we had a point 1, 3, we've got 3 of our 4 components of slope-intercept form. We're just going to substitute them in. M, x, and y, find c. The 1 goes where the x is, the 3 goes where the y is, solve for c, rearrange it, and lo and behold, we get back to the same point without having to know any of this stuff. This is actually a bit quicker. This requires you to remember less things. Whichever one is easiest for you, I would suggest doing. If you understand both, pick the one that's quicker. If you just want to focus on slope-intercept form, do that. And I think that's all I want to cover. Thank you, everybody.